On August 9, 2025 at 04:15, a single Ukrainian drone makes a one-way flight via Ukrainian airspace to Russia's biggest military drone plant. Every month, this plant creates 500 drones that destroy cities in Ukraine. The lone Ukrainian drone will be able to alter everything in 10 hours. It must first endure the following 30 seconds, though. A Ukrainian air defense position is passed by the drone. There is no identification, no data link, no IFF transponder, simply continuous flying that resembles a Russian attack. The radar of the Ukrainian Gepard instantly activates. Two 35mm cannons that rotate to follow. The intercept solution is calculated by the fire control computer, 8 kilometers presently. The operator looks intently at his scope. A Bayraktar TB2 profile corresponds to the contact. TB2s had previously been taken by the Russians and used against Ukrainian forces. His finger lingers over the firing button after being hit close to Bakhmut with this precise approach profile. His tungsten shots would destroy any drone in a matter of seconds at this distance. Then he recalls the briefing at midnight. Avoid engaging aerial objects at 150 m altitude, plus or minus 5, at 150 km/h, plus or minus 10, across these precise coordinates between 04:20 and 04:30 hours. There was no explanation provided. There is no background information given. It is 0419 on his watch. The window will open in 1 minute. 4 kilometers in closing. The firing control indicates a 94% chance of a hit. Every instinct begs to participate. It was being tracked by a self-propelled Ukrainian-Japanese SPAG anti-aircraft gun. These two 35mm Oerlikon autocannons were capable of firing 800 rounds per minute. Each shell contains 152 tungsten sub-projectiles, which explode at a set distance to produce a deadly cloud exactly where the victim would be. Flying through that tungsten storm would be impossible for any drone to survive. 8 kilometers presently. The operator was bothered by something even though the fire control computer was already calculating the position. Drones from Ukraine were launched at night in preparation for dawn strikes. Not at 04:15. To avoid friendly fire, they flew high. Not at 150 meters, where they may be hit by every rifle. 7 kilometers. It was clearly painted by the radar. Wingspan of 12 meters. Configuration with 2 booms. Unquestionably a Bayraktar, or at least what he believed to be a Bayraktar. TB2s had previously been taken prisoner by the Russians and used against Ukrainian forces. One had used Russian flight patterns to strike close to Bakhmut last month, but this one flew toward Russian territory while adhering to Ukrainian approach regulations. I'm presently 6 kilometers away. The drone remained on course as if it were on rails. Reconnaissance drones and other evasive movers were not used. No change in altitude to evade detection. Absolutely no electromagnetic radiation. Once it crossed the borders at 150 meters, it would be seen from every Russian point. Unless the drone had no intention of returning, this exposure profile made little tactical sense. 5 kilometers at 04:20. The window was open. The controls are tightened by the operator's hands. He had seconds to stop it if it was a Russian TB2 that had been seized. He would destroy the mission if it were a Ukrainian one. A 94% hit probability was displayed by the firing control computer. The ideal range is 4 km in 5 seconds. Every instinct begs to participate. However, those parameters were exactly right. Precisely 150 km/h, precisely 100 meters through the designated corridor. He could now see the drone straight via his optics. This was an AN-196 Liutyi drone, not a TB2. There is just one possible interpretation of this. At 04:26, the operator witnessed the Liutyi pass overhead and disappear. Now that Russian land was in front of them, morning stories about an unstoppable drone would soon begin to circulate throughout their command hierarchy. Sector Command in Bryansk received 3 reports of anomalies by 06:30. The identical contact was reported by observation sites along the border. The drone is moving slowly at a height of 50 meters, heading 087 degrees, not reacting to electronic obstacles, and staying en route. A straight line toward Nizhny Novgorod was displayed on the tactical display, and the projection went straight to Alabuga from there. The duty officer gave the order to deploy Pole 21 to grid reference 445892 right away. This is the Pole 21 GPS jammer. In essence, a military truck is equipped with a mobile broadcasting tower. On both GPS frequencies, the 15-meter antenna mast emits 1,000 watts of electrical noise. It produces a 20-kilometer bubble where satellite navigation is no longer possible. Drones are affected by the signal intensity at 90 dBm, although actual GPS is at 130 dBm. That is 10,000 times more powerful, similar to attempting to hear a whisper next to a jet engine. At 6:34, the AN-196 entered the jamming code. The operator counted down the anticipated sequence while keeping an eye on his scope. Jamming takes 3 seconds to overload the receiver. The drone takes 5 seconds to detect a communication loss. It takes 10 seconds to start the lost link process, which typically involves circling or going back home. The drone wobbled slightly at 8 seconds when the INS attempted to making up for missed GPS. It should have started to turn at 10 seconds. It remained unturned. It steadied and kept going east. The operator entered the spoofing mode. The Pole 21 was no longer merely jamming. False satellite signals were being broadcast to trick any GPS receiver into believing it was 500 kilometers away from its real location. The drone would progressively veer off course until its fuel ran out as it began to adjust toward this imaginary spot. The bogus signals were totally disregarded by the Liutyi. Something complex was discovered by analyzing its flight route. The drone was doing more than just tracking the railroad. Too easy to ambush, too predictable. Rather, it was making use of several terrain references. At the characteristic S-curve next to Selzo, drive 10 km on the M3 highway. Heading should be adjusted 15 degrees north. Follow electricity lines until they come into contact with the river. Instead of crossing at the 2-span bridge, cross at the 3-span bridge. Every route was selected for its individuality. Impossible to misunderstand. Total autonomy was achieved by visual navigation. No control to override, no GPS to disrupt. Each Pole 21 unit cost the Russians $8 million. GPS rejection took thousands of technical hours to master. By educating the drone to watch where it was heading, Ukraine had defeated it. Nizhny Novgorod's S-400 battery received the notice. Inbound drone, ETA 9:45. Alabuga receives a preliminary warning. Drone intrusion could occur. Moderate confidence. The estimated time of arrival is 11:50. Russian electronic warfare operators were tracking something that shouldn't be there by 800. With each milestone taking it closer to Alabuga, where 5,500 Shahed drones waited in warehouses before being deployed over Ukrainian skies, the drone navigated precisely through GPS darkness, following highways, rivers, and power lines like a traveler with a perfect map. The S-400 batteries near Nizhny Novgorod has been monitoring anomaly reports for 3 hours at 09:45. A GPS-immune drone that was approaching them had been lost by Bryansk. Their radar would now locate it. This system is the S-400's eyes, the 92 N6E Tombstone radar. These panels have 10,000 transmit-receive modules that can pump out 100 kilowatts of concentrated radiation in the S-band 2 to 4 GHz against a target the size of a fighter with a radar cross-section of 3 square meters. Although the detection range is up to 250 kilometers, tiny targets are severely harmed by radar physics. The AN-196 is 6 times smaller than a fighter, measuring just 0.5 meters. There is no linear decrease in detection range. It is based on the radar cross-section ratio's 4th root. This math reduces the detection distance from 250 kilometers to just 107. Even worse, the drone was exploiting the curvature of the Earth as a shield, while flying at a height of 50 meters. The drone ascended to a height of 200 meters at 09:45 in order to avoid obstacles. The radar instantly locked onto a slow-moving UAV with a range of 89 kilometers and bearing 262. The categorization was clear. Twin boom configuration, 12-meter wingspan, potential TB2 Bayar. However, the location was not feasible. The range of Turkish drones was 300 kilometers. Ukraine was 900 kilometers away from this interaction. The timing couldn't be worse. At 1000 hours, the shift changes. There were 13 minutes remaining for the nighttime crew. I'm already checking out mentally. It took until 10:15 for the day crew to be completely organized. This was the gap that no one discussed. No one wants to make important judgments for 15 minutes. In the direction of Alabuga, the track displayed an exact straight line. Not the roving pattern of surveillance, nor the searching manner of reconnaissance. This involved arrow-straight navigation to a certain destination. The S-400 Panzer connection becomes crucial at this point. The S-400 uses its $2 million 48 and 6DM missiles to combat long-range threats. Designed with high-value targets in mind, the Panzer's 30mm autocannons and smaller missiles offer close-quarters defense. They collaborated to create overlapping fields of fire by exchanging radar data. However, there is a geometric fault in the system. The cannons of the Panzer cannot descend beyond 5 deg. The required angle is E7 degrees at a range of 4 kilometers and an altitude of 50 meters. The drone was actually flying beneath the firearms. According to doctrine, the costly missiles were only intended for more serious threats. It was beyond the reach of the inexpensive autocannons. The contact disappeared into the debris of the ground as it dropped back to 50 meters. In essence, ground clutter is radar's blind spot. Every reflection that bounces off hills, trees, houses, and other topography produces noise on the screen. The drone disappears into the turmoil like a needle in a haystack, and the radar operators observe a jumble of static where the earth meets the sky. The log entry was produced by the overnight supervisor. A potential UAV contact bearing 087 was evaluated as reconnaissance. Lost in the litter of the earth. Nothing was done. When the day shift finally inspected the logs at 10:15, the treasure had moved 40 kilometers away. The novice operator examined his scope. There is nothing there. False returns are frequently caused by morning thermals. He brushed it off. The alert to Alabuga was revised. Verified drone approach. High self-assurance. 1150 hours is the predicted arrival time. Several systems had not connected. At Alabuga, the counter-drone operators started getting their equipment ready. Where conventional air defense had failed, they had specially designed counter-drone systems. However, unlike the Ukrainians, they weren't counting on anything special. Alabuga's counter-drone station had been monitoring the incoming threat for hours at 11:47. At 06:30, Bryansk reported a GPS jamming failure. At 09:45, Nizhny Novgorod recorded radar contact. It was now 8 kilometers away, flying directly at them in broad daylight while soaring 250 meters. The repelling system is the one you see here, designed specifically to halt drones. Any drone receiver within 2.5 kilometers will be overpowered by that directional antenna, which concentrates 500 watts into a 30-degree cone. There are 10,000 command protocols on the system's computer. Turkish military frequencies, NATO standards, Ukrainian protocols, Chinese commercial codes, and every frequency, standard, and override command ever utilized by drones. The system was turned on by the operator. The drone was subjected to 500 watts of electromagnetic energy, which cycled through all 10,000 orders in 4 seconds. Go back to your house. Land right away. Go into hover mode. Change to manual. Stop in an emergency. Every potential override was sent in every format imaginable. The AN-196 flew mechanically, straight, level, and unmodified. The next attack was frequency hopping. In an attempt to capture the drone in between hops, the system started striking particular frequencies at microsecond intervals. If you hit the proper frequency at the precise microsecond, even military encrypted equipment could malfunction. This had previously been successful with drones that were believed to be jam-resistant. No answer. 5-kilometer ending. In order to deceive the drone into turning the SAR VSS-5 GPS spoofer, joined the attack by broadcasting bogus satellite signals at 100 dBm, 1,000 times stronger than actual GPS, generating a phantom position 500 km away, and then gently walking it back. When it came to GPS-guided systems, this had never failed. The drone stayed on course for 3 kilometers. The terrible reality was exposed through analysis of its approach path. Visual landmarks were being followed by the drone. The water tower's main road. At the railroad intersection, make adjustments. At the river bend, correct. Pure optical navigation uses stored pictures to compare the topography. However, that wasn't the worst aspect. No sensor ball was taken out of the drone. There is still a satellite communication dome. No antenna arrays were disconnected. Where equipment should be, additional fuel tanks are welded. Not only were the control receivers turned off, they had been taken out physically. Cut and cap antenna cables. Uninstall the radio modules. The flight computer did not have an RF pathway. The drone they were attempting to hack had nothing to do with hacking. Every station began using barrage jamming. An electromagnetic storm between 100 MHz and 6 GHz is produced when 14 jammers open at the same time. Any CPU should be brought down by 50 watts per megahertz of pure noise from induced currents alone. The interference was not detected by the computers on the drone, which were enclosed in aluminum Faraday cages. The processors continued to function because of full electromagnetic shielding. Waypoint 1146 was reached. Go to waypoint 1147. Start the final descent. The AN-196 broke through the anti-drone mesh at 180 km/h at 11:52 high noon. In the face of 700 kg of aircraft, the steel grid intended for 5-kilogram quadcopters snapped quickly. The roof of the warehouse was breached by the thermite warhead. The chemistry happened right away. Aluminum plus iron oxide means 2500 degrees C, plus iron plus aluminum oxide. A stream of molten metal enters the shahets that are being stored. In 0.3 of a second, the first fuel tank burst. Massive overpressure was produced by an 8,000 to 1 fuel-vapor expansion ratio. 2 seconds. 50 drones exploded one after the other. 8 seconds. 3 atmospheres of pressure caused the roof structure to break. 15 seconds. The north wall was blasted outward. 30 seconds. Shahed swallowed all 5,500 of them. The fireball reached a height of 800 meters. 5 kilometers away, windows were broken by overpressure. Production took 6 months. Iranian technology worth $500 million vanished in less than a minute. In the era of autonomous warfare, one long-range drone demonstrated that all the sophisticated defenses were only costly systems yelling at a drone that was unable to hear them. For now, bye.